All right, so this is page 353, 6, 8, 11, 13 through 15. So number 6, show that it is a legitimate probability distribution. You could have done a lot of work and shown that you did all the work in a very short amount of writing by writing what? What about that? Not just this equals 1, but there's also another thing.
Oh yeah, it's y.
Make sure what?
It's y.
Oh yeah, sorry. That's what you're saying. Is what?
Is between 0 and 1.
So it gave the letter Y, so I should have had a Y here, a Y here. And then so you're making sure that each individual probability is between 0 and 1, and you're making sure that the sum of all the probabilities equals 1. So I did all that, but some people are going to write out like 0.68 plus 0.05 and so forth equals 1. That's fine too. This is where I hate the way the book calls it a histogram. I mean, technically, if you have bars, it could start, this could be 0, this could be 1, but why would you do that? Because this is categorical or discrete variables. I don't like that they call that at all. I wish I would have told you guys to just do. But, I mean, it didn't look like anybody had issues with it unless it just annoyed them as much as it annoyed me. So, what do you definitely notice about the histogram, or about the graph? There's one thing that everybody should be able to say about it. It was definitely very obviously what? Right skewed. It was right skewed, which means the majority of the time things are happening on the left side towards the low numbers, and as the variable increases, the frequency decreases. So in context here, that would have meant a lot of the kids, this is the one with a lot of the people exercised 0 times in the last 7 days, with the amount of days, as the amount of days increased, the probability or the amount of people who did that decreased. It's unimodal. Most often people haven't worked out at all in the last 7 days. That one's pretty generic talking about that. All right, so what does y less than 7 in words? This part should not be any more complicated than you think it is. So what does y minus or less than 7 mean? So just this without probability means what? They worked out less than 7 days out of the last 7. So what is the probability that y is less than 7 would be all of these added together. And right now this seems super basic. As we get into tomorrow's stuff, it kind of makes sense with why we're starting here. What is the same thing as saying probability that y is less than 7 in this scenario? The complement of the probability that y, you said what? And wouldn't that be a whole lot easier to do than this one? So what is the probability that y equals 7? So our answer is, and that's how I would have chosen to show my work for this problem. Otherwise, you could write this and then write out all of these and add them all up, but this way is going to be a whole lot easier. So the probability, or what's the opposite of people who didn't work, or who did work out less than 7 days? That would mean only the people who did work out all 7 out of 7 days, which is what this one's talking about. Express the event worked out at least once in terms of y. So that would mean that y is what? when we dealt with our yellow chart Z table, greater than and greater than or equal to didn't mean any different because the area of a line doesn't change anything. We didn't shade an area. Obviously here it's going to matter. So which numbers are at least 1? Starting where? 1 all the way up to. So what's not? So this is another one where writing this would be a lot easier as writing this. So I can do the complement of what I don't want. And I get that. Okay, so with this one, what outcomes make up the event A? So it works out at least once. It's kind of bad that it's the same context type as the other problem. But so this is saying, write it in terms of y. So y here would be what? Which is the problem we just did from the other one, just the different numbers. So probability of A, which is probability that y is greater than or equal to 1. Same thing as 1 minus the probability that y equals 0. Am I dealing with the same problem or did I copy over the wrong problem?
That's correct.
It's the same numbers. Oh, this is the one where it just relates them. Okay, so probability B works out less than 5. So this is y is what? Less than 5. So if I wanted to write this one in terms of a complement, and you don't have to do it this way because it's about the same, probability of B equals probability that y is less than 5, which if I wrote it as a complement, and like I said, you don't need to, it would be 1 minus the probability that y is what? So which means 5 would be included with this one, 5 would not be included with this one. So basically I'm taking 1 minus probability that y equals 5 plus probability that y equals 6 plus probability that y equals 7 and then finding the complement of that. So these 3 together give me how much? 0.07. So 1 minus 0.07. Or you could write that you're adding up all of those. I just think it's easier, still easier to do that way. So A and B means they work out at least once, and they work out less than 5 times per week. So which numbers satisfy both of those? So 1 is my first number that does. What's my last number that does? So it ends up taking those and adding them together. And then I don't care about the way you wrote that one because here I'm trying to tie in the idea of complement. Here you're not tying in the idea of complement. So I would probably just write it as probability of y equals 1 plus y equals 2 plus probability of y equals 3 plus probability of y equals 4.
And it's not equal to the probability of A and the probability of B because of the overlap, right?
Say that again.
It says y is the probability
Oh.
equal to.
So what are we checking if those would be equal? Dependency. So if they are not equal, then they are not independent. Alright, so how do I find mu of x? So tell me, starting to write out my work, what would I write? What's the first number I would look at? And do what with it? And then I would,
Plus 1 times 2 plus 2.
and you end up getting what? What are our units here?
Errors, number errors.
I'm going to give you a definition for this today, but it does say interpret it. So what does that mean to be interpreted? Is it if I do every single one that I do? Is if I do one, I expect to get exactly that many? No, it's that if I do it, what are we talking about? What are our units here? Individuals, sorry. What are individuals be? So it's not that if I look at one of them, there's going to be this many. It's that if I look at how many, a whole bunch of them or all of them, in the long run,
The average.
I would expect that to be the average. So we're going to kind of talk about that as an interpretation, but you should be looking at if I were to take all of them and split them up equally, that's how many each one of them would have gotten. Oh, this is a neat one. Explain what the mean of a random variable lies located at the side. Just as answer. It's the middle, and what do I started out all of our conversations this way and said, where's the middle? Now which way do we think it's going to go?
Well, they're all the same. So
They're all the same. So this is a what kind of graph? Uniform. So because they're all the same, it's uniform, it's not going to be pulled one way or the other. So that's kind of like in relation to the way I was asking questions in the class. This one in particular, though, is talking about faking your monthly expense reports. I took a class this summer that was all on sampling, and the dude he worked for Medicare fraud, like did a lot with Medicare fraud, and this is like one of the ways they actually catch people with stuff like this, because the distribution of the number, the weird stuff, like the end numbers of your different payment amounts should be uniformly distributed. But people who are making it up don't think about that, and they aren't. And that's one of the ways that they start catching people with weird stuff like this, which is interesting. So I would have never thought about that. So the first digit of randomly selected expense report actually follow that law. What's the expected value of the first digit? What's that going to be? Well, it is this. So what is the expected value? Oh, that's his exercise 5. Am I looking at the wrong thing?
The exercise time. Yeah. They also use.
we have to go back to probably didn't work on.
I didn't copy it. Okay. That's what I also did copy. So it's the one where the distribution is not like this. Sorry, I should have copied that right one over here. And what's the expected value of that first digit? For this problem.
3.44.
I might have to go back and copy that one over. I don't want to mess up if I don't have it in front of me to talk about it.
What do you mean?
Let me skip over that for now. I don't want to talk about it if I don't have it in front of me, because that's not fair to be able to talk about it this way. All right, so then 14, we've got this table, and it says a 21-year-old male pays $100,000 life insurance policy, insured until the next 5 years. Probability that they will die each year is found in the mortality tables. The company collects a $250 premium each year for that 5-year life insurance policy. So the profit here, what's going to keep happening to this profit? It decreases by $250. because that's your cost each year. So it's whose perspective is the profit here? The company. So like if the company had to pay out $100,000, they would have gotten the $250 from you, but still had to pay the $100,000 for a difference of this. But they're in the hole, so that's where the negative's coming from. If someone died at age 23 using this policy, they would have paid that $250 3 times, so it would have kept going down. So it would negative $99,250, negative $99,000. Why does it say 26 or more? At the next, it's only for the next 5 years. So if they make it to 26, what happens? The company makes the money off of your $250 each 5 years, but doesn't have to pay you. So what goes right here? Does everybody understand that? Because there's nothing that they had to pay out if you made it that long. All they get is the money that you paid them. How do I figure out what this is?
Wait, can you say that one more time?
If I'm only doing a 5-year insurance policy, so if you make it past 5 years, you're out of your insurance policy. So I don't have to pay you anything.
But you pay all that other stuff.
So this is in terms of the company. The company ended up with this much money from you.
Oh,
So how do I figure out what this probability is? It's just the complement of all those. Add them up and see how much is left. What do you get as your mean? $303.13. Would I write that in terms of what would my units be? Dollars. So on average, in the long run, with lots of 21-year-olds buying this 5-year life insurance policy, what does that 303 mean? Per policy.
why don't they make the 1,250?
Because they have to account for the fact that sometimes they had to pay it out. So like sometimes they have to pay out the $100,000. So in the long run, if they took everybody's and accounted for all the money they collected and the money they paid out and split it equally among how many people bought the life insurance policy, that's where the 303 comes from. That's how much average profit they would have. And last one, in 15 when I stopped. I didn't want you to interpret yet because I want to give you the sentence here. What do you get as your standard deviation for this problem? 1.1358. Everybody have a calculator. Everybody get a calculator. I've got some up here if you need them. All right, so if we are going to do this particular problem in our calculator, what's the first thing that I do?
If we're doing what?
If we're doing this particular problem in our calculator to find mean and standard deviation, what's the first thing I do?
Put it in list.
So what do we put in list 1?
1, 2, 3, 4.
All right, so go ahead and in list 1, write 0, 1, 2, 3, 4.
How do we get to listing?
Stat edit. Where do I put 0.1, 0.2, 0.3, 0.3, 0.1? List 2. I have never taught using the method I'm about to teach you right now. And I was very timid about doing so because this is the only thing that you can use this for. And we use this feature a lot. Start like you're going to do one variable statistics. So go to stat, calc, one variable stat. Well, which list is our values in? List 1. So we're doing it of list 1. What's my other option? So what frequency do I want to give to that list? What weight do I want to give to that list? You can put L2 there because it applies the weights of the probabilities.
I don't know what that means.
So like it accounts for 0 counts as 10%. 1 counts as 2% or 20%.
Oh.
So when you do that, what do you get as your mean?
1.135.
Your mean.
Oh, yeah.
What do you get as your standard deviation? Which are the same numbers we just got, right? So my concern here is if you do this and you try to go do another problem and use anything with one variable statistics and forget to delete where it says frequency list, then you mess yourself up with other options. So that's now, is this a whole lot easier than doing it by hand? Absolutely. Is it a whole lot easier doing it in the calculator? Absolutely. But it is a very specific time to use it. So if you remember to do your frequency list as your list 2, but you also remember that if you ever use one variable stats for anything else, you've got to clear that part. So you see the give and take here? It's not that I don't think you can remember to do this. It's that I worry that you'll forget to delete it for everything else. So you may use this option. If in the future you decide to use this option, I still want to see some work. You can still write out your work. That shouldn't change anything.
So we can use this when we have these tables and stuff.
Yeah. So just remember that when typically your frequency list is blank, if you want to do it with a probability distribution like this, you use your probabilities as your frequency list. Questions with that? Okay.